Hello and welcome to my video, lesson 1.1a. We're looking at the first half, division of polynomials. So we're going to do a little bit of long division here and then some synthetic division. Just before we even get into that, let's just remember that we can divide long division when there are big numbers, and it's really the same process. So let's just put this in place, and we're going to divide this by 3. So what we do is we look in the first column, and can we divide by 3? No. So that first column is going to be 0. Now, we often don't write the 0, but for now, let's write the 0, and then we can move on. So first column is 0. Then we look at the second column. Can you divide by 3? Yes, if you divide by 3, so 12 divided by 3 is 4, and then 4 times 3 is that full 12. So basically asking how many times can we fit into that number, how many times can we fit in our number that we're dividing by, so 3 in this case. So then we subtract, we bring the other numbers down, so now we have 96. So now we look in the next column, so every time we just have to make sure we are looking at columns, right? So as long as you stay in the columns, you will hopefully understand this. So we're going to look at the next column, which is 9, so we can fit it in 3 times. So 9, so 3 times 3 is 9, so we subtract by 9. So then we drag down the next column, which is 6. We can fit into that 2 times, and we subtract, and we get a remainder of 0. And just a reminder, when it's a remainder of 0, that means that it is a factor. Okay, so let's take a look at some of these examples here today, and then this lesson and the one next after it both kind of combine together to give you a good idea of how to get the factors of polynomials. So today we're looking at division of polynomials first. And it's using this long division idea, but using it in the form of polynomials. So again, the same kind of rules apply. You kind of see how much does it fit into, and then you subtract. So let's look here at our first example. Let's just maybe give myself a little bit more space. And now I've moved that thing. That's okay. We'll probably have to remove this again. But we're doing long division. Okay, so first things first, we're asking how many times can x fit into x cubed? Actually, not even. We're asking how many times this fits into here. So that's a little bit of a process, but you're going to have to think about it in terms of this column. Just like if you have a 2-digit long division regularly, you'd have to think about the second column. Like how we had 12 divided by 3, right? We had to think about it in that sense. Okay, so we have to look at the next column. So when we put it up here, we're going to be putting it in this spot. So actually, because it's a binomial, we always start with 0 plus. So we're not going to have an x cubed term because to get to x cubed, to subtract by that value, we have to multiply it by x squared. So to fit it in, we are going to subtract by this value, which is subtracting by our original times by our x squared. So those two are being multiplied together to give us that value. Then we bring down the 2 extra values here, so minus x, minus 3. And we subtract, the first column disappears. The second column gets minus 4x squared. Now we look at this column and we try to subtract something. Minus 3 is going to come down for sure. But let's put negative 4x squared. So that means we're going to have negative 4x. If we multiply by that for our first term times this x here, that's how we get our answer. And then multiply it by plus 1, so we get to there. The first column disappears, they cancel. The second column goes to plus 4 minus 1, so positive 3x. So it looks like we're going to have to multiply by 3. Okay, which would give us negative 6 as a remainder. I see a remainder 6, and we had to multiply by 3, so we have this, this answer here. So we didn't have a nice remainder this time, which means that x plus 1 is not a factor. All right, continuing on, we have x plus 3. We're going to divide by x plus 3. We're going to do the same thing here. If you could pause the video now, try it out for yourself, and see if you get the same answer I do. That is the best way to learn. So go ahead, pause the video, and try it yourself. All right, now I'm going to go ahead and do it. So we're subtracting by this, but to make it fit, we actually have to get cubed, so we have to multiply it by x squared. So it's going to look like this. These two values are going to come down. So, whoops, this should be x squared, cubed. And so we're going to be left with negative 5x squared minus 5x plus 6. Okay, we're going to do the same thing again, x plus 3. Okay, but the idea here is that we're trying to make it fit, so we have to multiply by a negative 5x to get that. So that means that we have negative 15x, just x. And the 6 comes down. This column will disappear. This column will be, plus 10x. Okay, and we'll do that again. X plus 3. So we're going to have plus 10. And then this would be plus 30. Again, it's not seeming to give us a nice remainder. So let's see here. This would give us negative 24. Well, that's okay for now. It doesn't really matter. In terms of this lesson, it doesn't matter if we have a nice remainder of 0 or not, but it should be a nice remainder if I did it right. So I must have made a mistake in my initial building of the question. All right, let's take a look at synthetic division, which is just that. It's synthetic. It's not really division in the normal sense, in the way that it doesn't really show what's going on. It's just a kind of procedural thing how we can get it. So what we do is we kind of just put a coefficient in front of each of these. So 1, 1, negative 4, negative 4. This first one will just come down, okay? But the what we're going to do is we're going to take the x plus 2 part, and actually let's do that in a different color. X plus 2, and we're going to rearrange it so it equals to 0, and then find x, so that's minus 2, so we're going to put that here. And now we're going to use that number in order to multiply down to the 1 and then multiply it across. Hold on. Go down. Yes, multiply across. So that number is the number that we're using to multiply across this way. Okay, so now we get, so we have 1 that comes straight down, then we get negative 2, which brings down negative 1, and then negative 1 times 2, so it's positive 2, which gives us a negative 2. Multiply it across, it gives us positive 4, and so that gets us to 0. So the reason for all this is it's a kind of a crazy way of getting there, but it's a faster way of doing the division. And so if we take these numbers, so 1x squared minus 1x minus 2, remainder 0. So if we divide the purple by the red part, this is what we get as an answer. And then we can get rid of the coefficients of 1 because we don't really need those. So synthetic division is kind of helpful. It's kind of weird, but it's kind of helpful at times as well. Let's try it again with our next one. 1, 4, 1, 1. 1 comes down. Okay, now we look at this x minus 1, and we make it equal to 0. Then we solve for x to make that plus 1. That goes here, and that's the number we're multiplying by in each of these cases. So 1. Then we add the numbers together. So 5. Then we go 5. And we add the numbers together, so we get 6. Then we go times 1, get 6. And we add the numbers together, and we get 7. So, with all of that in mind, this one is going to be x squared plus 5x plus 6 remainder 7. All right, so that is both methods of dividing polynomials by a binomial, long division and synthetic division. I hope this video helps you understand both a little bit better. Good luck.